to that, if that's okay. There are, of course, dealing with this data, just like any other this utility sensitive data, code of conduct issues where, there's marketing constraints on who can have access to this data. So people that were may possibly able to hijack that information could obviously have insider trading kind of capabilities. So there's those kind of concerns. But you have those kind of concerns with any kind of data coming from a substation. But outside that, like you mentioned, there is obviously concern if you actually do have access to the device and you compromise it, you could do some really bad things. But that's true, again, of a lot of devices in the substation. But that one reason alone is one of the driving factors, going back to your prior question, about why a lot of people like to separate the protective relay function from the PMU functionality. So the driving forces behind some of those concerns. And ways to mitigate those with technology, making it a unicast only kind of feed, or do you want to make sure it's command controlled? So there's ways to get the data off. One of the other bigger issues, as you step out higher, sort of as a data exchange layer between two utilities, there are issues with data sharing. Because if I'm sharing my data with my neighbor, and my neighbor has a set of university students running a study, and suppose this new information at the high resolution provides them some kind of insight to faults on my system. How much access, now suddenly you're sort of in an illegal kind of environment where you could have been at fault because of some kind of issue, or there's money and high stakes poker involved here. Even though there's very important reasons why you want to share this data and make sure everybody can prevent those kind of future things from happening, there is some resistance at a very high level dealing with confidentiality and sharing as you get up higher dealing with this data.
I would also like to add that during this deployment process that we have today, PMUs are being deployed sparsely throughout the grid. So a loss of one creates a huge blind spot in the area. The other devices that provide the same functionality but a lot slower, RTUs, remote terminating units, and their sampling is 1 every 2 to 4 seconds. That's usually we use the analogy between an X-ray and an MRI on these devices. But they are deployed close together. They have a lot more numbers in the field. So if one goes down or compromised, you can use a state estimator to compensate. During this phase, until we are fully deployed, we will have that risk. One compromise for any reason, it will create that blind spot in the grid for the operations and planning. Also, one other advantage to have by having a separate unit that causes the issue integrity of that data. We never know if we're receiving the correct data. One of the things that is not, the question that is up in the air is where we put integrity. The best place is the source. If you put anywhere in between, even a single hop, somebody can introduce themselves in the middle and modify the data. Currently, there's no requirement, there's no IEEE standards that manufacturers can introduce integrity on a device itself. It's not like the C37118 that's the way PMUs and SynchroPhasors communicate, and you have to validate that communication is in compliance with that standard. There's nothing that can address integrity or security for that matter of fact. C37118 is inherently there's no security, and it is left to other layers of the network to introduce that security.
So we'll just add really quickly, while that is absolutely true, we'll say, in terms of keep an eye on this space, track IEC 61850-90-5. That's a new portion of 61850 that is in development right now that addresses several of the issues that William brought up.
Okay. I think we might have time for one more quick question, Brian.
I just want to follow on to that one. Is that approach a greenfield approach, or is it going to be a add-on?
90-5?
Yeah.
90-5 is, I hesitate to label it as an add-on, but it does, basically, C37.118 does a perfectly fine job of describing the payload data, of saying, here's what a phasor is, here's how you measure it, everything along those lines. So there's really not any need to go and re-engineer that. And so the folks from IEC TC57, which is Power Systems, Working Group 10, which is Communications and Information Modeling, so didn't really see a need to go redo that portion, and they're essentially treating the C37.118 data structure as, you know, as the payload, and then building a lot more functionality that comes from other aspects of 61850, such as self-description and some integrity checks and so on, building that into the envelope.
Great.
You answered my question.
All right. I think we're right on time. Gentlemen, thank you for your time. I think we've had a good insight, talked about AMI stuff from the 15-minute data. Now we're down to the 30-millisecond data.
First of all, I want to say thank you very much. I actually believe I understand SynchroPhasors now and some of the security issues, and I know this is an ongoing process, and we're going to learn more as we go along, and I'm sure the bad guys are going to figure out some more interesting things to do with SynchroPhasors and PMUs as they continue to be deployed. And it's good to know that you got, you know, people working on this, and that the government is giving you guys money to do it. So, you know, thank you very much.